What you're about to watch is a full module from the UniFi Network Masterclass. This is my paid training course with Crosstalk's network expert David Barger, where we walk you through designing, deploying, and configuring UniFi Network from start to finish. It's nearly 4 hours worth of content across 13 separate modules. And so far, the response has been really awesome. We've already received many 4- and 5-star reviews from our students. This particular module that you're about to watch is all about deployment planning, or in other words, how do we here at Crosstalk actually approach designing a network for our customers? What questions do we ask? How do we account for building materials and floor plans and device counts, internet connections, and budget? This is the real world stuff that we do every single day here at Crosstalk Solutions. So please enjoy this free preview, and if you want to check out the full course, head on over to masterclass.crosstalksolutions.com. All right, without further ado, please enjoy our UniFi Network Masterclass segment on deployment planning. All right, so now let's talk a little bit about deployment planning. And what do I mean by that? Basically, how do you design a network for a customer? Or when you're approaching a customer about designing a new network, what type of stuff do you need to ask that customer? Now, we do this all the time, and kind of the way that I like to approach it, just from a 10,000-foot view, is I think of the network almost like a public utility, right? It should be like plumbing. Like if you think about plumbing, you never really think about plumbing until there's a problem with the plumbing, right? Like if your toilet's all of a sudden not flushing, now that's a problem that you're worried about, right? I kind of think of the network that way. I want to design and build a network that is so solid and stable and reliable that our customers don't ever have to think about it, right? It just works. So here are some of the questions that we ask customers when we first approach them. So number one, what kind of business is it, right? Or what is the primary use for the location where we're installing this network? Makes a big difference. Is it a warehouse? Is it a school? Is it a hospital? Is it just a standard commercial office building, right? So all of those things have various little nuances that you learn to work with over time. Any special deployments that you like or like to avoid?
Yeah, so we deal with them a lot, but there's some really complicated ones like warehouses. I mean, a warehouse is a huge row of basically shelves, and whatever's on that shelf, if you got to take that into account. The other thing about that is you can't hang access points off the shelf because the high-lows can knock them off. So there are many really complicated deployments, but that's pretty high up on my list.
Yeah, not to mention very, very tall ceilings usually.
Yes, that is right.
So the other question would be, how many users or devices are we expecting to support on this network? How many of those are wired and how many of those are wireless? Now, this doesn't have to be an exact count, but we kind of like to have a notion of like, oh, there's typically going to be 200 wireless devices, people with smartphones and, IoT devices and that thing. And then we've got, 50 computers that are plugged in. We kind of like to have that, those types of numbers. We also want to know about their internet connection. What is their internet connection? Is it cable? Is it fiber? Are they on Starlink with CGNAT, right? What's the speed? How many internet connections do they have? Do they have multiple paths to the internet? And what also is available at that location if they need multiple paths to the internet? The other thing we like to ask is, what do you have there now, right? What kind of stuff is in place already? Because depending on a customer's budget, we might not just be ripping out every single thing that they have. We might be able to reuse a lot of the equipment that already exists, such as, just layer 2 switches or pretty much just layer 2 switches. And, they'll work with any brand of firewall and wireless access point. So we don't necessarily need to rip everything out, but we do want a good inventory of what's there so we can say, okay, we're going to keep this stuff in order to save on budget, but we have some important pieces that we are definitely going to want to account for in the network design. Anything to add to that?
Yeah, that ask about what do you have in your existing deployment is huge. A lot of our consulting is remote consulting, so we can't go walk around and find this. That generally brings up a lot of good conversation around, exactly what they have, how things are laid out, really cues us in as if we could walk around, and does tell us about some of the pain points too.
Yeah. So the next one is the construction of the building, and this is important in a number of ways. For Wi-Fi, it's important because wireless signals penetrate through different materials more or less depending on the type of material. Something that's brick or concrete is going to block wireless signals. Certainly if there's like a kitchen with a lot of metal equipment in there, that's going to block wireless signals. But something like standard US drywall framing construction, internet or Wi-Fi goes through those walls pretty well. The other consideration is for wired. If you have an all concrete building, it's much more difficult to run wires where you need to run those wires versus if you have a standard office like drop ceiling where you can just have a clear path to shoot wires wherever you need them. Another thing that we like to do is request floor plans. Floor plans, we'll show you a design tool in a moment that helps a lot, but bringing those floor plans into a design tool really helps give us the sort of initial stab at a simulation of especially what the wireless is going to look like. But it's also very handy for, hey, we're going to put the firewall here and we're going to have switches here and here. And it can also estimate the amount of cabling that we are going to possibly need for the deployment. And then we get into ancillary stuff like VPN. Do you have VPN requirements? Is this a remote office that needs to have a site-to-site VPN to another location, or is it part of a bigger campus? And then a couple of other things that we just like to ask customers in general is, what are your existing pain points? Like, you're hiring us to work on your network for a reason. Is it a brand new install and you just don't know how to design it? You want a good network? Or do you have an existing network, but you're coming to us because it's not working for you? If it's not working for you, why is it not working? What are those pain points that you're trying to address? It might be wireless coverage. It might be network speed. It might be broadcast storms and they have the networks, slowing down like crazy. Who knows what it might be? But we always like to ask the customer, hey, what specifically do you want fixed or addressed so that after the deployment, we can make sure we test for those things. And then finally, and oftentimes one of the most important things, what is it, Dave?
Budget.
Yeah, budget. Not only budget, but budget and timeline. So what are you looking to pay for this? And sometimes a client doesn't know. Sometimes a client's like, just give me a quote and then I'll look at your quote. Sometimes we have to do multiple quotes. So for example, if they have an existing infrastructure, we might do multiple quotes. One quote to just replace everything that they have, and then another quote that's like a more phased approach, or we're going to replace what we think is the key elements that need to be replaced or improved, but then we're going to keep these other things in place in order to save on that budget. And of course, timeline always factors in as well. Timeline, especially for schools, sometimes they only have time to make a major change to the network during summer when there's no kids in school, stuff like that. So we always like to ask, how quickly are you looking to get this done? It also factors into our timeline, whereas, someone might want something next week and we're booked out till next month. So all of that factors in. Anything to add to that?
It's always the triple constraint of timeline, budget, and quality, and just trying to get those three things to work the best for the client.
Yeah, exactly. So we're going to now step through a deployment and just kind of give you an idea of how we would approach a particular situation. So here we have a commercial project. This is going to be just like a standard medium-sized office deployment. In this case, we've got an office supply company. They've got approximately 20 employees. They're going to have sales and support and HR, just generally what you would find in a standard corporate office environment. For each desk, now I typically like to recommend to clients that they have 2 Ethernet drops per desk. And the reason that we do that is not just so that we have options, so we have extra Ethernet ports, but usually we like to do a PC as well as a voice over IP phone, because most of these places are going to have a phone system and they're going to have voice over IP phones. One thing to know about that though is if you don't have access, this is an existing deployment, you don't have the ability to put in the drops, put in 2 drops at each desk, you only have 1 drop. Almost every single voice over IP phone on the market that I know of today has a little 2-port network switch on the back where you can go from the wall to the phone and then from the phone out to the computer. Typically that's also going to be gigabit, but sometimes it's 10/100. So you just want to be cognizant of not bottlenecking a computer by running it through a 10/100 switch on the back of the phone. So we're looking at about 60 network drops total, assuming that each desk is going to have 2 Ethernet ports plus some miscellaneous. And then the construction of this building, we're looking at a concrete exterior with drywall and timber framing for the interior walls. They are going to want a VPN to a central office. And then if we look at the floor plan here, we can see that they will probably need about 2 access points. This is a pretty standard size office environment with about 20 employees. So let's take a break here for 1 second, and we are going to pop over to a tool called the Hamina Planner, which is going to allow us to drop access points into this floor plan and simulate what the wireless coverage might look like. So here is Hamina. Did you do the exterior walls on this one?
You know, I think I had it do the auto setup, so we'll see here.
So the exterior walls are probably just, let's look at the 3D view. Yeah, it's probably doing drywall on the exterior wall. Right. So the first thing you'd want to do if you're using a tool like this, which by the way, this is Hamina Planner, but there are many tools that do this same kind of thing, including UniFi or Ubiquiti has their own. It's the UniFi Design Center. It's a little bit more limited in what it can do versus something like Hamina, meaning that it's only specific to Ubiquiti hardware, whereas Hamina works, kind of agnostically with any hardware that you might have, but it also does work with Ubiquiti. And what we would want to do here is kind of go through and make concrete walls all around the exterior. And then you want to come over here to access points, pick your access point. In this case, we're going to go with Ubiquiti U6 Pros. This is a very solid access point. And then we're going to drop a couple onto this floor plan. And you should see pretty quickly our wireless coverage change to account for those 2 access points. And right down here, you can see that we are on 5 gigahertz, but we can also switch that over to 2.4 gigahertz since these are Wi-Fi 6 access points. And you can see that the coverage is actually pretty good. It's actually really good. It's perfect in 2.4 gigahertz. And then if we go to 5 gigahertz, there's very few spots where we're not getting coverage. Looks like this toilet down here might not get great coverage, but other than that, the rest of it looks pretty well covered. And what you can do here is kind of move these around to make sure that you've got the best coverage possible. The other thing you can do is if you have an existing floor plan, or if they have existing wireless access points, you can simulate those by putting them in. One of the things that we've found with some customer deployments, especially when they don't really understand Wi-Fi and how Wi-Fi works, is customers will put too many access points into a deployment. And then they're calling us and saying, hey, stuff's not working. My devices are not connecting to the right access points. Why don't you walk through the problem with too many access points?
Yeah, so in the traditional AP versus client relationship, it's always actually up to the client itself to decide which AP it wants to connect to. A lot of people think it's the other way, where the AP is actually saying, hey, let's have this iPhone connect to me. It's the other way. So whenever you're, let's say for example, an iPhone walking around a building, if you have too many APs to choose from, it can get confused and you can have roaming issues. So what we do in this situation where we have too many APs, we'll first take a first brush across this, maybe turn off a couple APs if needed, or at the very least, maybe turn off some of the 2.4 gigahertz APs, at least on the 2.4 gigahertz range, because we know that goes very far compared to 5 gigahertz. And of course, then we're going to make some other changes that help that iPhone make a better decision. We're going to stagger all of the channels of 2.4 and 5 so they don't overlap as much as possible. And we may do some other tricks like minimum data rate controls to just help that device clue in on which AP it should connect to.
Yeah, so really planning out and designing the access points The way we say it is it's both an art and a science. All right. So sometimes when you have these access points, and we're gonna dig actually pretty deep into this when we get into the wireless portion of this series, but you have a lot of knobs that you can tweak when it comes to access points. You've got the channel width, you've got the actual channel that a spectrum is broadcasting on. You've got the output power of the access point. So there's a lot of things that you can tweak and tune, which, by the way, you can tweak and tune all of those things here in Hamina Planner, so give you the simulation. But what we like to do is if there's a problem with the Wi-Fi at a customer site, we will take our best guess at what the problem is. Too many access points, maybe cut down the output power, take some of those access points out of the mix, and then let it sit for a week and let the client sit with it for a week and see how it changes, see if they're still having issues, see if there's still areas that need coverage or are not working as well as they should, and then tweak further from there. So that's sort of the art and the science of wireless deployment design. Okay, so one of the things that we are going to do as part of this tutorial series is we are going to build this network right here. Now, this is very generic. This is kind of a generic network that we use when we're evaluating like new equipment from new vendors, etc. We want to make sure that it can do all of the stuff that you see in this diagram right here. So let's step through this. In this case, we've got a cable internet connection, 800 megabits. And that's pretty good. Pretty standard, I would say, for a SMB environment. If you have multi-gigabit fiber, though, there are different considerations for the type of equipment that you can use. We're going to talk about that in the next segment. We're going to want to have a router, which is, also known as a gateway, also known as a firewall. These are different things, but they're typically combined into a single device. We are going to want to have some sort of VPN connection out to a corporate office, so we will take that into consideration. We already know that 2 access points is probably about right for this deployment, so we're going to have 2 access points, and then we're going to have a couple of switches. Now, in this particular deployment, we saw that we had a need for about 60 drops, so what we would recommend is 2 48-port switches. That way you can split the 60 drops between those 2 switches, but also, if one of the switches fails, you've got enough ports where you can take the most critical drops and make sure that they're plugged into that switch until you can replace the one that failed. And then we're going to create 4 separate VLANs. We're going to have one for management. That's basically your network, your switches, your router, your access points. Those will live on the default VLAN 1 management network. Then we're going to create a VLAN for the office PCs. This is kind of our main network where we're going to have printers and just all of the stuff, any servers, the actual PCs. There's an argument to be made whether that's where you put the voice over IP stuff, or does the voice over IP go into its own VLAN? We'll talk about that more in detail. Then we're going to create a VLAN for guests. So this is not just for guest wireless. This would also be for employee devices, employees' personal devices. So if you've got your own iPhone that's not a corporate iPhone, you don't necessarily want that to be on that secure main office network. We want to segregate those out into the guest network. And then finally, we'll create a VLAN 4. In this case, we're just calling it an IoT VLAN, but some other use cases for a completely separate VLAN would be voice over IP, for example, or a surveillance system. Oftentimes, if you have a camera system, you don't necessarily want that camera system to have any sort of internet access, or those cameras shouldn't have internet access. Maybe the NVR itself does so that it can pull updates and stuff like that. But again, there's a lot of arguments to be made. By and large, I try to go with as few VLANs as makes sense, because if you have too many VLANs, the administration of the network can start to get out of control. What do you think?
I agree. We see that all the time. Customers come in with way too many VLANs. Let's start simple.
So we're going to need a router. We're going to need a couple switches. We're going to need a couple of access points. And the next thing we need to do, though, is understand when it comes to UniFi, what are all of those bits and pieces, right? And how do those fit together? And which ones do we actually want to use for a deployment like this? So that is going to be our next video, which is understanding software-defined networking. And then we're going to get into equipment selection.